Hello, and welcome to Deep Dive on Amazon S3 Express OneZone. Thanks for spending your evening with us. My name is Matt Sibley. I'm a senior manager of product management on Amazon S3. I'm joined by Shaki Hawley, a principal product manager on Amazon S3, Christy Lee, a principal storage solution architect, and Ambad Sharma, tech lead of data engineering at Pinterest. We've got a packed agenda today. To start, we'll overview S3 Express OneZone, our new high-performance storage class. We'll talk about why we built it, how it helps application performance, and dive into the details of how it works. Then Shaki will talk about some of the use cases and partner solutions, and how S3 Express OneZone improves performance and reduces TCO. Then Christy will walk through a demo on how to get started with S3 Express OneZone and show off a few performance numbers. And then Ambad will share how Pinterest is using S3 Express OneZone to accelerate their machine learning pipelines. So why did we build S3 Express OneZone? You know, if you look at Amazon S3 today, customers use S3 for a wide variety of use cases and achieve very high performance, from everything from data lakes to genomics to origin storage for CDNs. And customers use S3 for these performance-critical applications because S3 has this massive front end, which customers can scale applications to millions of requests per second. For example, it's not uncommon for a customer to scan petabytes of data in a data lake and achieve terabits per second of throughput. However, there's a number of applications out there, whether that's video editing or interactive analytics, that need lower latency because the speed of access impacts the job time or query time. And these applications are often waiting on the request to complete before the next step can be taken. Another common pattern is in data pipelines, where data can go through multiple stages, and each stage is dependent on the previous stage completing. You know, as a result, some customers move their most frequently accessed data of their performance-critical applications to custom caching solutions to reduce storage latency. However, this increases complexity because now you must maintain additional storage infrastructure and multiple sets of APIs. So for these workloads, we built S3 Express OneZone. It's a new high-performance storage class that delivers the lowest latency and highest performance object storage in the cloud. It provides up to 10 times faster access speed than Amazon S3 standard and supports millions of requests per minute, all while using those same S3 APIs that many customers are already familiar with. So how does S3 Express OneZone help latency-sensitive applications? Let's go back to that data pipeline example where the compute tasks are waiting on the storage I/O to complete. For these request-intensive applications, S3 Express OneZone's very low latency means that your compute time has spent less idle time waiting on storage. And so as a result, your job or query time completes faster. A good example of this is model training with Ansets Capital. Ansets Capital is a quantitative trading team that leverages world-class technology in combination with some of the brightest technical minds. Ansets trains models for very high-frequency trading continuously over extensive amounts of time series data to stay updated on the lightning-fast pace of the financial markets. With S3 Express OneZone, they saw a 78% improvement in workload speed, which allows them to scale their models to higher levels of granularity across asset classes and points in time. So speed is a great benefit when you need a job to complete faster to meet a specific business objective, but it can also save you costs. With S3 Express OneZone, that reduction in compute time or compute idle time in combination with the 50% lower request costs of S3 Express OneZone, we're seeing customers save up to 60% in the total cost of ownership of that application. So I think the thing everyone's curious about is how does S3 Express OneZone actually achieve this very high performance? It uses a unique architecture that is optimized for performance to deliver that very low single-digit, consistent single-digit millisecond latency. First, and how it achieves this is first it stores data in a single zone on purpose-built hardware and high-performance hardware. The second aspect to further increase that access speed is it introduces a new bucket type, which we call S3 directory buckets. These new bucket type can support hundreds of thousands of TPS and allows customers to scale very quickly with their object storage. The third is S3 Express One Zone. You use a new session-based authorization model that is optimized to provide that lowest latency for requests. All three of these in combination provide the lowest latency and highest performance. And we'll dive each of these and how they work in the next few slides. All right, so first let's talk a little bit about the one zone architecture. Today, by default, Amazon S3 stores data redundantly across a minimum of 3 availability zones. For example, on a write, data is stored durably across these 3 AZs before returning a 200 success. This provides the highest resiliency and durability. With directory buckets, you specify that availability zone, and it gives you that option to co-locate storage and object storage and compute in the same AZ to further reduce latency. When you use S3 Express One Zone, data is stored redundantly in that single AZ instead of multiple AZs. And with a one zone architecture, there's a couple of considerations to think about. First is the AZ placement. While storing data in the same AZ as your compute provides the lowest latency, if you store data in a different AZ, there's no additional network costs. And so like all Amazon S3 storage classes, there's no inter-AZ data transfer costs. Second, one zone storage classes have a different durability model than S3's regional storage classes. So let's talk more about that durability model. S3 Express One Zone has end-to-end integrity checking on every object upload and verifies that all data is correctly uploaded. Next, data is redundantly stored across multiple devices before it considers your upload to be successful. Once your data is stored in S3, S3 continuously monitors data durability over time with periodic integrity checks. S3 also actively monitors the redundancy of your data to help verify that the objects that you've created can tolerate concurrent failures of multiple storage devices. And all 3 of these apply to all Amazon S3 storage classes. With S3 Express One Zone, there is a difference, and it is important. In the unlikely case of loss or damage to all or part of an AWS availability zone, data in a one zone storage class may be lost. For example, like fires or water damage could result in data loss. So it is something to think about before placing your data in the storage class. With S3 Express One Zone, we're also introducing a new bucket type, a new S3 directory bucket, which supports hundreds of thousands of requests per second. And so with this launch, there's now 2 different bucket types within S3. What we call now the general purpose bucket, which supports storage classes like S3 Standard, Intelligent Tiering, and the new S3 Directory bucket, which supports the S3 Express One Zone storage class. And one of the key differences between these bucket types is how they scale. With general purpose buckets, the transactions per second can be very high, but scale incrementally under load. With directory buckets, buckets are scaled to hundreds of thousands of TPS, and what this means is that workloads can now burst very quickly with very high transaction rates. The third piece of this puzzle to provide this very high performance is a new auth mechanism. With S3 Express One Zone, you authenticate and authorize requests through a new session-based mechanism, which we call S3 Create Session, which is optimized to provide that very low latency. When you use S3 Create Session to request temporary credentials that provide low latency access to the bucket. These temporary credentials are scoped to a specific S3 directory bucket and can be scoped to 2 types of modes, a read-only or read-write mode. Then, after the session is created, and once that call is made, a token is returned and is used on subsequent requests. The management of the sessions and tokens are all automated within the latest SDKs. So we'd recommend as a best practice to use the latest SDK, and all of this is handled for you. The create session is specified in the bucket policy. Here, you allow for the action of the create session and specify in the condition statement if the session mode should be read-only or read-write. So to sum up everything we discussed, when you're architecting for high performance using S3 Express OneZone, you first create a directory bucket, which scales to hundreds of thousands of TPS. You will co-locate that directory bucket and storage with your compute resources in the same AZ to achieve the highest performance. Then use the new session-based auth model, S3 create session, which automatically is managed for you in the SDKs. There's some use cases that will require you to move data from an existing S3 storage class or a data lake from an S3 bucket to S3 Express OneZone. And the natural question is, what's the best way to do that? With this launch, we're also introducing single-step batch operations, which allows you to move data with a single step using S3 batch operations. If you're not familiar with S3 batch operations, it lets you easily perform one-time or recurring batch workloads, such as copying objects between buckets, and easily scales to millions of requests. With this new feature, you can copy objects from your general purpose bucket to your directory bucket. You can copy millions of objects in just a few minutes. All right, now I'm going to hand it off to Shaki to talk more about the use cases and partner solutions with S3 Express OneZone.
Thanks, Matt. So far, we learned about the performance characteristics of Express OneZone and how some of its new features help your workloads achieve the performance goals that we have set for the storage class. In this section, we will learn about the partner services that are supported with Express OneZone and how you can unlock the use cases with that. So let's get started. Our customers depend on a large number of AWS services to unlock value from S3 for their use cases, and that remains true for Express OneZone as well. So we built integration with key AWS services that we're going to cover now. First is monitoring and automation, where you can track key storage metrics with services like CloudWatch, resource tracking activity with services like CloudTrail, as well as automate your infrastructure with CloudFormation. Like previous S3 storage classes, security management is built in with services like IAM and VPC. To accelerate time to insights at lower cost, key analytical services like EMR and Athena are supporting Express OneZone today. Machine learning is a core use case with Amazon SageMaker and enabled with Express OneZone. Because customers will see the biggest benefit with compute, with the fastest performance, we have enabled integration with key compute services like EKS, EC2, and Lambda. And lastly, to continue our focus on developer tools, we have enabled automatic performance tuning with popular developer tools like MountPoint for S3, AWS SDK and CLI, S3A connector, and PyTorch connector for S3. We will now cover use cases in detail for 4 key services where we think you can differentiate on performance with S3 Express OneZone. First is Athena, that accelerates your performance with SQL queries by up to 2x. Today, you are using Athena for interactive querying workloads, where you use familiar SQL commands to join data across several data sources and store those results in Amazon S3 for later use. This provides a flexible way to ingest and analyze data while avoiding complex ETL pipelines. You can now use Express OneZone as a caching layer on top of your long-term S3 data lake. This will help accelerate time to insights for downstream applications, while also reducing your request cost by up to 50%. Next is EMR, where we tested Apache Spark queries now run up to 4 times faster with Express One Zone. So with traditional big data processing systems, a consistent pattern that we see is that storage is closely coupled with compute. So customers struggle to provision the appropriate amount of local storage that meets the requirements of their workload with unknown access patterns. Under-provisioned storage leads to out-of-memory errors, whereas over-provisioned storage wastes space. Another pattern that we see is provisioning of additional storage to maintain multiple copies of your data to protect against system failures. With Express One Zone, you get a high-performance storage that does not require any pre-provisioning and scales independently of your compute workload. In addition, you no longer have to maintain data redundancy because Express One Zone automatically maintains 3 copies of your data to provide the high durability. So you can now use Express One Zone as the intermediate data store for your big data processing workloads. For your Spark workloads that read and write from S3 standard today, performance will be up to 4 times faster when you use Express One Zone to accelerate your downstream applications like QuickSight dashboards, machine learning training, and other analytical dashboards. Your workloads not only benefit from the faster data access, but also the reduced cost and the reduced operational overhead. Third is Amazon SageMaker, where we tested that machine learning applications now run 5.8 times faster on Express One Zone than S3 standard in fast file mode. So as Matt covered earlier, compute is often stalled by storage access times, leading to spiky utilization of provisioned compute resources. And with deep learning models growing in size to nearly billions of parameters today, GPUs often drive the biggest portion of your total cost of training models. So even the smallest optimizations to your compute resources can result in needle-moving savings, both in terms of training time and costs. So we conducted internal benchmarking tests to train a deep learning model called Vision Transformer for image classification and used about 1 million images for a training data set. And because Express One Zone delivers consistent single-digit millisecond latency, even at P99, we found that it resulted in a more consistent and efficient utilization of your GPU resources, leading to faster job runtimes and savings in training costs by up to 16% over S3 standard. So how does this work with in-built machine learning AWS services? Customers often use SageMaker to train their models directly from their training data in S3 and then store their trained models for machine learning inference back in S3. Training a deep learning model with S3 Express One Zone is not just faster, it also helps you utilize your compute efficiently. So for example, in our internal benchmark tests, training the same Vision Transformer model with Amazon SageMaker fast file mode, we saw that it was 5.8 times faster than S3 standard. And lastly, Express One Zone is now also supported with Mount Point for S3, a new high-performance file client for S3 that we launched earlier this year, which runs up to 6 times faster than S3 standard. With Mount Point, customers can translate local file system calls to S3 API calls, and then can use it to mount an S3 bucket on their compute instances as a local file system for their machine learning workloads and analytical applications. And with Express One Zone, you can now achieve even faster performance for these workloads to reduce your request costs and optimize your compute usage. We understand that our customers use a wide range of services with S3. So we work closely with our AWS partners to seamlessly integrate Express One Zone and unlock the performance and cost benefits for our customers. Customers use Cloudera platform to build an open data lakehouse to manage their cloud and on-premises data. With Express One Zone, customers can get up to 40% improved read and write performance for this use case. Similarly, a number of S3 customers use ClickHouse to build an open source database for their downstream analytical applications. And with S3 Express One Zone, their platform speeds up query performance by 283% and lowers TCO by 65%. Chaos Search uses an S3 native live analytics database to facilitate search queries using SQL. They were able to see up to 60% faster query time and substantial infrastructure cost savings with Express One Zone. ColorFront offers a media editing platform to process and deliver media for their Hollywood and entertainment customers. Starting today, ColorFront customers can improve the performance for their digital processing workloads by up to 70%. And that's not all. We would like to thank more than 20 AWS partner services that span across analytics, machine learning, media editing, governance, backup that support Express One Zone to achieve the fastest performance for our customer workloads. And with that, I will now hand over to Christy, who will walk us through a real-time demo of how to get started with S3 Express One Zone.
Thank you, Shafi. All right. So I'm Christy Lee. I'm a storage solutions architect, and I'm really excited to show you what you could do with S3 Express. If I don't get, OK, cool. I will use the laser pointer a little bit, and I'll try to bounce between the two screens just so that everyone in the room can see. It's because I didn't get enough steps while I was here at reInvent, so you'll have to forgive me. All right, you guys ready? OK. So there's three parts to the demo. The first part of the demo, we're going to show you how easy it is to get started. We're going to start somewhere familiar. We're going to start in the AWS console. We'll show you how to create a new S3 directory bucket. And then we'll go into how to easily import into that S3 bucket. OK. So logging into the AWS console, we'll browse to S3, hopefully a place that some of you have seen before. And you'll notice that there'll be two tabs at the top. One is for your general purpose buckets, the S3 that we know and love and has been around since 2006. That will be under your general purpose, but you'll also have a new tab for your directory buckets. OK? So let's go ahead and we'll set up a new bucket, make sure that we're in the expected region. All right. So once we've confirmed that we're in the region that we wish to deploy in, we'll select that we want to be deploying a new directory bucket. This is the first type of S3 bucket where you can specify which AZ you wish to deploy in. We'll go ahead and select AZ number 5. Do keep in mind, like the name suggests, this is a one-zone service. So we will want you to acknowledge that in the event that that particular AZ is impacted, you may be unable to reach your data at that time. We'll pop in the bucket name that we would like, and then notice that the bucket name will be suffixed with the region and AZ and --x-s3. OK. By default, we'll turn on block public access. We'll have ACLs disabled on the bucket, and we'll also encrypt by default as well. And that's all you'll have to set to start with your new S3 directory bucket. OK, perfect. So now that we've got our bucket created, like all S3 buckets, when you first create one, it'll be empty. Looks a little lonely. Let's give it some friends. So we'll go back. You'll notice that if we select the bucket, there'll also be an import button that's presented to you on the top right. We'll select import. So the input that we'll need to tell it is where do we want to import from. This could either be a bucket or it could be a prefix within an existing bucket. The only requirement for your import source is that it has to be within the same region of where you're importing from. So North Virginia, US West, and so forth. For the demo, we've got a general purpose bucket that is set up with a sample data set. So we'll select that as our prefix to import. We then verify what role we want to use, confirm that that's the correct S3 directory bucket we want to import into. And once we're good, we'll hit next. Or rather, we'll hit the import button. So at this point, I will note that if you want to use the S3 Express OneZone storage class, those will have to live exclusively in those directory buckets. Your general purpose buckets is where your S3 Standard, Intelligent Tiering, Glacier, and so forth is where those objects would live. So naturally, any objects you copy over into a directory bucket will be S3 Express OneZone. So this is what we mentioned earlier in that single operation, batch operations. That's what import is doing. It's creating for you that batch operations job, telling it in bulk, I want to move X amount of objects, thousands of objects, millions of objects, may it be, into my S3 directory bucket. Here's one I completed earlier. It completed in a couple of minutes, and it easily moved 5,000 objects from that sample data set. A really quick and easy way for you to get started with setting up a directory bucket. Okay. And just to show, that sample data set did move into a test bucket. All right. So at this point, you're ready to start connecting your applications. Hopefully, you've chosen the same AZ for locating your compute as well. For the next part of the demo, we're going to do a download performance test. So 100,000 objects at 512 kilobytes in size. To give you the lay of the land, the top two terminals are connected to an EC2 instance, the same EC2 instance. The bottom two are connected to another, but same EC2 instance. So the top two are one and the bottom two are a different one. The top two are going to be talking to an S3 Express OneZone objects or an S3 directory bucket, and the bottom two are talking to a general purpose or S3 standard. And just for your information, the instance that we're going to be using is a R6 IN32X large. Yes. All right. So what I'm showing you here is the config file of how do we set up the test. This is a custom Python script that we use for setting up the test. And just to show you the parameters, so what we do is we just modify the config, make sure that that's the test we want to run. So it will be a download test or a GET request. The only difference between the two configs is one is talking to the S3 Express bucket and the other one's talking to a general purpose bucket. On the right-hand side, you'll see the network load performance stats. So we'll see as soon as we start the test, we'll see some graphs come up on the right side. We'll just take a moment to set up. All right. And then we'll hit enter. Okay. So exact same, identical test, only difference is two different buckets. Okay. S3 Express is finished. It finished in 5.3 seconds, downloading 100,000 objects from an S3 directory bucket. Note that the single-digit millisecond latency we got is an average of 8 milliseconds, and we'll get the S3 standard results when it finishes. It's still going. You can see the network chart on the right. It's still downloading. Now, I should mention that this is a synthetic test. Your applications will run a little bit differently. There's different ways to scale S3 performance. So this is just to show you what happens when we run from a single EC2 instance talking to S3. Okay? The S3 standard test is done. So for the same test of downloading 100,000 objects, average latency is about 80 milliseconds, and we got about 1 gigabyte per second of throughput, whereas S3 Express, we got about 9 gigabytes of throughput. So there will still be the majority of use cases, we do expect customers to continue to use S3 general purpose and S3 standard and similar storage classes. But for those low latency workloads, we do expect our customers to consider if S3 Express would be a good fit for them. Let's try another performance test, but this time we're going to modify the config file for the S3 Express instance to 1 million, to downloading 1 million objects. We'll keep the S3 standard test the same, where we're just downloading 100,000 objects. We'll see how this goes. All right, we'll kick those off. We should see those network load charts come up. Yep, okay. So if you look at the numbers on the right, I know they might be a little bit tiny for the people at the back. So we're pushing about 11 gigabytes per second, and then about, I think that's one. About one? Yep, thank you. So for those high throughput workloads, you should be able to see that there would be a considerable difference, but it really will depend on your use case. So something to think about. Now, most customers, I would expect that they would distribute the computing when it comes to using S3 Express so that they can get that benefit of hundreds of thousands of TPS per second. Okay, both tests are done. So both of them completed in around roughly 40 seconds or so, but one was doing 10 times more, so 1 million versus 100,000, download for objects. So pretty cool, while still keeping that single-digit millisecond latency. I think that's pretty cool as a storage person. So, all right. Hopefully you found that as interesting as I did. Oh, yeah. And then I also have TPS numbers in there. So 22,000 TPS for the S3 Express and about 2,000, almost 3,000 for S3 Standard. All right. Let's move on to the third section of our demo. So Jackie mentioned some of the benefits for especially our analytics services, including Amazon Athena. So Amazon Athena, we're going to try seeing something similar. If we've got a data set in S3 Standard and we've got a data set in S3 Express 1 zone, let's see how they do. So for this demo, I have a sample data set of about 100 gigabytes. The only difference is that they are mirrored and stored in 2 different buckets. We'll set up our query table. We'll set up our table so that we can query it in just a moment. Same config for create table. The only difference is pointing to a different S3 bucket. Okay, once that's set up, we'll pop in our queries. Yep, we just need to make sure that this table appear. Okay. Yeah, so looking from this side, S3 Standard's here, S3 Express is here. Okay? All right. So for the first query, we'll do a simple one. The data set we have is sample game data. So we're going to take a look at transactions for customer spend for a gaming platform. Exact same query. The only difference is we're querying 2 different tables, and the 2 different tables are querying 2 different mirrored data sets. So we'll let those run. It shouldn't take too long. Okay. All right, so for the S3 Standard table, we see that the runtime for the simple query is about 16 seconds on that 100 gigabyte data set. And for S3 Express, took about 12 seconds for that 100 gigabyte data set. So roughly 33% improvement or for 4 seconds. Let's try a slightly more complex query, or at least the most complex one that I can write. So this time we're still going to do select statements, but we're going to do a table join. All right, same idea, same data set. We'll let those run, let those go. Okay, S3 Express is finished. And S3 general purpose is done. Okay, so same data set. The S3 standard finished in about 20 seconds, and S3 Express finished in about 12 seconds for a slightly more complex SQL query. So for customers, I imagine that they would use this to all sorts of possibilities, all sorts of use cases when it comes to analytics. But it's really those where you do have those performance-critical workloads that do require that low latency. That's where it's worth considering where S3 Express would be a good fit for your environments. So speaking of use cases, I would like to welcome our co-presenter, Amrit Sharma. Thank you, Amrit.
Thanks, Christy. How's everyone doing? Awesome. Hey, so let's quickly take a look at what Pinterest is first, right, before we dive into S3 Express. So Pinterest is a visual inspiration platform for discovering and shopping the best ideas in the world. It's basically like a digital bazaar. And I frequently use Pinterest myself for my woodworking hobby and as well as home improvements. So with that said, let's see what makes Pinterest work behind the scene. Pinterest infrastructure. So here's a quick overview of what we're doing. We have over 300 plus services that are built using shared services stack and a lot of open source technologies, running over tens of thousands of EC2 instances at exabyte scale data in Amazon S3. And having been born in cloud has taught us a few things over the last decade. First and foremost is stateful and stateless systems scale very differently. Stateful systems will often require data replication, rebalancing, and repartitioning. And doing so, it could take days or hours or days, and depending on the size of the data. Therefore, to achieve scalability in the cloud, it's imperative that we use storage and compute and separate them out. And it's also interesting that doing so has an impact on efficiency. Running custom replication in the cloud can be expensive. And last but not least, Amazon S3 provides some very powerful primitives which allow us to use efficiency with economies of scale. So these four primitives is something that we have learned over the years. And also over these years, we have seen two evergreen challenges for Pinterest. First is scalability, right? Our scale grows. And the second thing is efficiency. So scalability, let's define that. For us, that is the time to serve business needs. How long does it take to scale up our services? How long does it take to launch a new feature? Or if you had an existing feature, how long does it take to scale that up? And the second part is cost, right? The cost of doing business. So and it really matters to us. So can we do both, right? Have scalability and efficiency at the same time? And how does that impact our both operational and infrastructure expenses, right? So when we talk about cost, it's not just about infrastructure costs. There's an operational component to it as well, right? How long does it take to do operations on a cluster? So let's try to take a look at these challenges through the lens of a use case at Pinterest, a platform at Pinterest called our data ingestion stack. And this thing powers our ads, our home feed, and much, much more. Basically, if there's data flowing through it, in Pinterest, it's going to go through the stack. And from a scale perspective, we process about over 80 million events per second. That's about 7 trillion events a day. And that's pushing over 2 petabytes of compressed data through the pipeline. And this entire architecture is using, at the heart of it is publish-subscribe system, right? Which is PubSub. It's producers and applications generating data, storing, and the PubSub system is replicating and providing durability to it. And then the consumer applications could be consuming the data in near real time, or in batch cases in some cases. So we asked ourselves, well, we have to build this scalability. How do we do that better? And could we use the powers of Amazon S3 to do it? The answer was yes. In 2018, we started on a journey and an idea that could we use Amazon S3 to build a PubSub system natively, which means the PubSub system would use S3 as the replicated data storage engine. And because it would decouple the storage and serving components due to the fundamental design, it would allow us to have on-demand scalability, as the team covered previously in multiple slides. And the idea there is that because the data is sitting in Amazon S3, we don't have to worry about data rereplication, rebalancing. All of that is nearly instantaneous. All of that is metadata operation. And we built a system that we call MemQ. And with MemQ, we're able to power our machine learning pipeline, specifically our training data, which is by volume about 50% of the total pipeline that we're talking about in terms of both data volume and event volume. And being able to do that to satisfy business needs where machine learning engineers may be working on a new feature, and when that feature gets added, the pipeline spikes to 2 to 3 times. They may be doing validation, which would, again, do on-demand spikes on the data. And doing so in a traditional system would be very, very challenging because, well, we have to get the capacities ramped up, scaling, rebalancing. With MemQ, it's literally a metadata operation happens in seconds. So with those powers and capabilities, we were able to scale this environment since 2018 to be able to run 50% of the total traffic for PubSub. But there's a trade-off, like it sounds too good to be true, right? And the trade-off here is latency. We have to buffer data to be able to write seamlessly to Amazon S3 so as to be more efficiently used as we saw that there's a difference in the request rates Amazon S3 standard can serve versus Express One Zone can serve. That's the difference we're talking about. And to add more color to it, this is totally fine if you're trying to do batch data analytics offline training, right? You just want to make sure the data is durably stored in your environment and being able to be served by your offline processing applications on demand. So what we try to do in here is we're like, okay, this is all good and great, but could we power sub-second storage with this? Well, the answer now is yes. With Amazon S3 Express One Zone, coupled with MemQ, we're able to take the efficiency of MemQ, which is 90% cost reduction, and apply it in the Amazon S3 Express One Zone low latency case, and run sub-second pipelines through this. How does that work? Well, all we had to do was apply code changes to accommodate for the new session token, and pretty much rest was literally a drop-in replacement. So let's see some performance data. But before we get into the performance analysis, we should also check out what the setup of our performance looks like. What we try to do is use our standard logging pipeline, which is the most common use case for applications at Pinterest, which is a microservice generating log data. And we call pretty much every data, we kind of picture that as log data. We take that pipeline, configure it at 1 megabyte object size. And the reason we use 1 megabyte in this case is because we were trying to compare to S3 standard. And we had done tests in the past for S3 standard with 1 megabyte. So we had good historic data to compare the results against. The second thing is we ran it at a throughput about 3 gigabytes per second, which was representative of our large use case. And then the KPIs we care about in this case were latency distribution, and in this case specifically, last byte tail latency. So your writes are not acknowledged until you get, your writes are not durable until you get acknowledgement from the storage system that there's a 200 write acknowledged from the storage system, and you can't acknowledge the data back to your client until that happens. Therefore, last byte latencies are very, very important. And the second part is consistency of throughput, right? If the system is jittering everywhere, you cannot predict memory requirements because your buffering requirements will be all over the place. So let's see what the results look like. Here's a graph of our throughput over time during our testing. What you're seeing is the inbound, outbound traffic on the MemQ cluster. And the brief spike can be ignored because that was client rebalancing. So what you can see, take away from this chart is you see a consistent graph with throughput being nearly consistent and jittering very, very little. And that just speaks to the performance capabilities of Amazon S3 Express One Zone. Let's look at the latency, right? The talk of the town, right? Which is P99 latencies, we see hovering around 30 milliseconds for the test that we ran. There's a nuance here because of certain constraints. We were not able to run the test in the same availability zone. So this is actually going across availability zone. And you can see the 30 millisecond flat latency curve that you're seeing here. The other thing that to mention here is that we care about put latencies. As I said, that if we really care about last byte put latencies to acknowledge the data back to storage so that we can tell the producer that, hey, you're OK to keep moving forward and writing more data because we have written it durably to the end storage. For the same setup in Amazon S3 standard, MemQ sees latencies around 2 seconds. And as you can see, this is around 30 milliseconds. It's a remarkable difference in performance here. Let's see what the end-to-end latencies look like, right? Because that's what the application sees, right? The 30 millisecond latency for puts is great for MemQ looking at it, but what does it look like for the end-to-end latency? We saw a consistent sub 300 millisecond latency for this test, and then just speaks to, again, the consistency of performance that we see. So what's the impact of this? Well, it first eliminates the I/O and storage capacity planning, as was being mentioned before. And the time it takes to provision things, right? How long does it take for your EC2 instances to spool up is pretty much the time it takes for MemQ to scale up and start serving new workload. In addition, you also see TCO improvements. In our case, the test that we shared and the use cases that we are concerned about here, we see a reduction of up to 40% on the total cost for the use case, as well as the scalability, on-demand scalability for the use case is over 50% because there's less operational cost to have engineers go provision things and then allow engineers to be able to serve more workload through the pipeline. So what's next? So we want to roll out MemQ and Amazon S3 Express One Zone. As you know, the service was just announced. We also have a few use cases. As we came up with this design pattern in 2018, there's other areas where we can apply the same design pattern: buffering, applying and decoupling storage and serving. First one is Shuffle service, which is Spark Shuffle service. If you have shuffle data being generated, and as you saw, if there's out-of-disk errors, you will have jobs retrying, and that's bad because that adds to your total cost of ownership. The second one is dataset cache. When you have hot data and you want to be able to quickly get access to it, quickly access to pre-materialized insights, we want to be able to potentially leverage this technology. And then last but not the least, when we have extra large value storage in our key value store, it makes total sense to not have that be stored in memory. We can use a new technology to do that, and that's Amazon S3 Express One Zone here. With that said, I'll pass it back to Shaki for a quick overview of the entire presentation.
Thanks, Sampath. To wrap up, we want to cover 3 key takeaways. First, S3 Express One Zone is a new high-performance storage class that results in single-digit millisecond response latencies for your most compute-intensive applications and is up to 10 times faster than S3 standard. Second, to achieve the performance goals for this new storage class, we are introducing 3 new features: directory buckets for request-intensive workloads, create session API for a faster authentication authorization, and a single zone architecture to co-locate your storage and your compute. And third, so that your workloads can automatically start using this storage class, Express One Zone is natively integrated with a number of AWS and partner services. Thank you for attending this session and taking out time to learn more about S3 Express One Zone. We really value your feedback today and throughout the year that helps us build these products. And we hope that you have a great rest of your reInvent.